Hey everyone, welcome back to Astronomy Daily. I'm Anna.
And I'm Avery. And Anna, I feel like we need to issue a weather warning today. A space weather warning.
Very on brand for us. It's Monday, August 17th, Series 5, Episode 169. And yes, there is genuinely a solar storm rolling in as we speak. So we'll get to that.
We will. But first, our main story today is one of my favorites in a while. NASA just funded a concept for little spherical robots to go exploring the caves of Titan.
Which sounds like science fiction and is in fact just science.
Just science. Then we've got SpaceX quietly breaking its own launch record twice in one night, 38 minutes apart. Rocket Lab picking up its biggest defense contract yet for something called Flatellites, which is a genuinely fun word to say. And then we'll close out with that solar storm, because depending on where you live, you might want to look up tonight.
A very Monday lineup. Let's get into it.
Okay, so start us off. What exactly did NASA fund here?
So this is a NASA Innovative Advanced Concepts Grant, NIAC for short. That's NASA's program for funding the genuinely weird early stage, this might not work, but if it does, it's a game changer ideas. And the one that just got a Phase 1 grant is called SPARK, which stands for Solid State Propulsion for Autonomous Reconnaissance of Karst.
Karst being?
Karst is the geology term for terrain shaped by dissolving rock. On Earth, that's usually limestone, and it's what gives you sinkholes, underground rivers, cave systems, all of that. Titan, Saturn's biggest moon, has its own version, except instead of water carving through limestone, it's liquid methane and ethane carving through water ice, which behaves like rock at Titan's temperatures.
Right, because it's what, minus 179 degrees Celsius out there?
Roughly, yeah, properly cryogenic. So Titan's got these liquid methane lakes and rivers on the surface, and scientists think underneath there's a whole hidden landscape of sinkholes and caves, the same way you'd get in, say, Kentucky or Slovenia, just running on an entirely different chemistry.
And that's the terrain a normal rover just can't deal with.
Exactly. You can't drive a wheeled rover into a cave mouth or over a sinkhole edge, and flying a fixed rotorcraft in there is its own nightmare of collision risk. So the team behind SPARK, led by Daniel Drew, an assistant professor at the University of Hawaii, working with Ethan Schaler and Jacob Izraelevitz at JPL, and Michael Malaska at the Blue Marble Space Institute of Science, came up with something different. Small spherical robots that basically fly themselves through the terrain using electric propulsion. No propellers, no moving parts to brake.
No moving parts, so how do they actually move?
This is the clever bit. It's called electrohydrodynamic propulsion, or EHD. It's a solid-state electric thruster, similar in principle to the ion wind lifters people have been experimenting with here on Earth for years. Except this team is adapting it for Titan's specific atmosphere. Drew's own description of the advantage is basically the whole pitch. He says the design gives you persistence, maneuverability, robustness to the challenging near cryogenic conditions, and minimizes downwash disturbance of scientifically important hydrocarbon layering.
Break that last bit down for me. Downwash disturbance.
So if you fly a normal propeller drone into one of these caves, the prop wash, the air it's pushing down and around, would stir up and disturb the very hydrocarbon layers on the ground that scientists want to study undisturbed. A solid-state thruster barely moves the surrounding atmosphere in the same way, so it can hover and inspect a site without messing up the science.
That's such a specific, very Titan problem to have to design around.
It really is, and it's a good reminder that Titan is nothing like Mars with a moon in terms of engineering constraints. It actually works in the Aerobots' favor in one big way, though. Titan's atmosphere is denser than Earth's at the surface, and gravity is only about a seventh of Earth's. So flying there is weirdly easier than flying here. You get more lift for less power.
So it's almost the perfect place to fly a fleet of tiny spherical drones, other than the fact that it's over 1 billion kilometers away and colder than anywhere on Earth has ever been.
Just a few small logistical issues. But it's not the first time JPL circled this exact problem either. There was an earlier concept called shapeshifter. Cobots that could roll as a sphere, fly independently, link into daisy chains to descend into caves, or reconfigure into a swimming probe for the lakes. That one dates back to around 2019, led by JPL's Ali Agha, and it never flew, but it shows this has been a recurring puzzle for mission planners. How do you actually get eyes into Titan's caves and under its lake surfaces?
So Spark is sort of the next generation attempt at solving the same problem.
Right. A more focused, more mature approach to a piece of that puzzle. And in terms of where this sits right now, this is a NIAC Phase 1 award, which is 9 months of funding to mature the concept and prove out the physics. If it clears that bar, it can apply for a 2-year Phase 2 grant. This is very early stage. We're talking design studies and lab testing, not hardware headed to the launch pad.
Is there any actual mission this could hook into, or is it purely conceptual for now?
The obvious one people are asking about is Dragonfly. That's NASA's rotorcraft lander that's actually built and funded, targeting a Titan launch around 2028. Drew's been fairly upfront that integration with Dragonfly specifically isn't confirmed. This is really a technology maturation project first, looking for a ride on whatever future Titan mission makes sense, which could be an add-on to Dragonfly or something entirely separate down the line.
Why does any of this matter beyond tiny robot spheres are cool, though? Like, scientifically, what's actually at stake in those caves?
A few things. One, basic geology. Understanding how karst terrain forms in an entirely different chemical system tells us a lot about how erosion and landscape evolution work in general, not just on Titan. 2, and this is the bigger one, Titan's subsurface, especially anywhere liquid water might mix with those organic hydrocarbons, is one of the more interesting astrobiology targets in the solar system. It's not Europa or Enceladus with their subsurface oceans, but Titan has its own complex organic chemistry happening on the surface, and possibly just beneath it. And caves are exactly the kind of sheltered, chemically rich environment where you'd want to look closely.
Tiny spherical robots floating into alien sinkholes, hunting for the building blocks of life. When you put it that way, it's a pretty great pitch for 9 months of NIAC funding.
It really is. And this is exactly the kind of story I love bringing you, because 90% of these NIAC Phase 1 concepts never fly, but the ones that do reshape entire mission architectures years later. Worth keeping an eye on Spark as it moves through review.
Okay, moving on. From tiny robots on Titan to something happening a lot closer to home, SpaceX broke its own turnaround record this weekend.
Twice in one night, and not by a little.
So Saturday night, August 15th, SpaceX launched 2 separate Falcon 9 missions from opposite coasts, just 38 minutes apart. First one lifted off at 9:12 p.m. Eastern from Cape Canaveral Space Force Station in Florida, carrying 8 global star telecommunications satellites deployed over about a 6-minute span. Then at 9:50 p.m. Eastern, so barely more than half an hour later, a second Falcon 9 went up from Vandenberg Space Force Base in California, carrying a classified U.S. Space Force mission called USSF 366.
Classified as in, we don't fully know what's on it.
Right, though the reporting suggests it's likely built on the Starshield platform. That's SpaceX's national security variant of Starlink. But the headline here isn't really the payloads, it's the timing. 38 minutes between liftoffs from 2 different coasts. Beat SpaceX's own previous record of 65 minutes, which was set back in August 2024.
So they shaved 27 minutes off their own record.
Which doesn't sound like much until you think about what has to happen in that window. Different pads, different states, different mission control teams, weather, range safety clearances, all of it lining up almost simultaneously.
And both boosters landed successfully too, right?
Both stuck the landing. The Global Star booster completed its 14th flight, and the USSF 366 booster landed on the drone ship Of Course I Still Love You out in the Pacific. That one was on its 18th flight.
18 flights on a single booster is wild to say out loud. And now it's just Tuesday. Well, Saturday.
Just another day at the office for Falcon 9. And that's really the bigger story underneath the record. This pushes SpaceX's 2026 tally to 96 Falcon 9 launches so far this year, with roughly 3/4 of those dedicated to building out the Starlink constellation.
96 launches, and we're not even through August.
At that pace, they're on track to comfortably beat last year's total. It's honestly gone to the point where a single Falcon 9 launch barely makes news anymore. It takes something like 2 and 38 minutes from opposite coasts to actually stand out.
Which says a lot about how normalized orbital-class rocket launches have become in the space of about a decade.
It really does. We'll keep watching to see how long that 38-minute record holds, because at this cadence, I wouldn't bet on it lasting past the end of the year.
Speaking of defense contracts and companies racing to build out constellations, Rocket Lab just landed its biggest one yet.
Flatellites. I need everyone to appreciate that name for a second.
It's a great name. So this is a $397 million contract from the U.S. Space Force, awarded earlier this month, for Rocket Lab to build and launch a batch of satellites called Flatellites, flat panel satellites, hence the name, for a program called SBAMTI, Space-Based Airborne Moving Target Indicator.
Which is exactly what it sounds like, tracking moving airborne threats from space.
Right. It's about building a space-based sensing layer that can watch contested airspace in near real time. Rocket Lab CEO Peter Beck put it this way. He said, "We are proud to contribute to the deployment of a resilient space-based sensing layer that will enhance the joint forces' ability to operate in contested airspace."
And the flat design is the interesting engineering choice here.
Flat panel satellites stack far more efficiently inside a rocket fairing than traditional boxy satellite designs, so you can pack a lot more of them per launch. It's the same basic logic SpaceX used when it redesigned Starlink into a flat pack form factor. Each Flatellite is also fitted with low latency, high bandwidth communications alongside its threat detection sensors, so the whole constellation can talk to itself and to the ground quickly.
And these are flying on Neutron, Rocket Lab's new rocket, the one we were just talking about on Thursday's episode. That's still hedging on a 2026 debut?
Exactly the same Neutron. So there's a nice bit of continuity here. The rocket itself still doesn't have a confirmed first flight date, but customers keep signing up to fly on it anyway, stacked in a Starlink-style configuration once it does get off the ground.
That's either a huge vote of confidence or a slightly nerve-wracking amount of manifest riding on a rocket that hasn't flown yet.
A bit of both, honestly, but it does make sense in context. This is Rocket Lab's largest defense contract to date, and it's not their only one this year. Add up the other government contracts they've announced in 2026, $190 million, $90 million, and $266 million, and combined with this deal of $397 million, that's $943 million in defense funding secured this year alone.
Just shy of $1 billion, all in 2026.
Which tells you Rocket Lab's strategy of leaning hard into national security work alongside Electron's commercial track record is really paying off. It's positioning them as a legitimate second option to the primes in this space, not just a smaller player nipping at SpaceX's heels.
Reputation and revenue building up nicely while Neutron itself is still on the ground. We'll see if that first flight finally happens before the manifest gets too long to wait for. Okay, last story for today. And this one's genuinely live as we're recording. There's a geomagnetic storm expected to hit Earth today, August 17th.
This is the space weather warning I teased at the top.
It is. So the setup is a double coronal mass ejection, 2 CMEs, combined with a high-speed solar wind stream all heading our way. Forecasters, including the British Geological Survey, are predicting G1 to G2 level geomagnetic storming, so minor to moderate on the scale that runs up to G5.
And the timing. When's this actually supposed to arrive?
The geomagnetic background's already been a bit unsettled since yesterday, the 16th. But the main impact is expected in the second half of today as the bulk of that solar material reaches Earth.
So basically tonight, depending on your time zone.
Basically tonight. And the fun part for listeners is the aurora potential. Forecasters are calling for possible displays at high latitudes. Based on similar recent storms this season, that's put places like Scotland, Northern England, Northern Ireland, Alaska, Canada, and the northern tier of the U.S. from Washington state to Maine in the potential viewing zone. And in the southern hemisphere, keep an eye out if you're in southern New Zealand or Tasmania.
Solid excuse to step outside tonight if you're anywhere in that band.
Definitely worth a look. This is coming off a pretty active stretch from the sun generally. One active region in particular, sunspot AR4507, fired off at least 10 C-class flares in a single 24-hour window between the 15th and 16th, including the strongest one, a C3.7, right around 3:31 UTC on the 16th.
No M or X class flares in that batch, so nothing extreme, but a genuinely busy sun.
Which tracks, we're in an active phase of the current 11-year solar cycle, and there's been a steady run of filament eruptions, flares, and Earth-directed CMEs over the past few months. This is very much part of that pattern, not a one-off.
I did see one slightly funny detail in the coverage: space weather experts advising that people who are sensitive to weather changes or who have cardiovascular conditions might want to keep stress low, stay hydrated, and go easy on caffeine and alcohol during the storm.
Which is genuinely sound advice, regardless of what the sun's doing. But sure, blame it on the CME.
Also worth flagging, forecast models don't fully agree yet on exact timing. So this could still arrive a little later or even end up being more of a glancing blow than a direct hit. Space weather forecasting is still much fuzzier than the terrestrial kind.
So no guarantees, but if you're in the right latitude band and the sky is clear tonight, it's worth stepping outside and looking up.
Which is basically our whole show in one sentence. All right, that's our 4 stories for today. Quick recap. NASA's funded an early-stage concept called SPARC, spherical propeller-free Aerobots that could one day fly into the methane-carved caves of Titan. SpaceX broke its own launch turnaround record with 2 Falcon 9 missions just 38 minutes apart from opposite coasts. Rocket Lab landed a $397 million Space Force contract to build flat satellites for airborne threat tracking. And there's a geomagnetic storm arriving today that could bring aurora to parts of the northern and southern high latitudes tonight.
If you enjoyed today's episode, the best thing you can do for us is leave a rating or review wherever you're listening and share the episode with a fellow space nerd. You can find full show notes, sources, and links for every story we covered today at astronomydaily.io, and find us on social media. We're at AstroDailyPod pretty much everywhere.
We'll be back tomorrow with another episode. Until then, keep looking up. Tonight, especially.
See you next then. Clear skies.